Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 55 in our legendary series of epic tutorials on the Arduino microcontroller. What I will need you to do today is pour yourself a nice big mug of iced coffee. Refreshing. I will need you to get out your Lego Super Starter Kit. If you don't have one, look in the description down below. There is a link. Pick one up for $35 and you can do all of the lessons in this tutorial with the components that are in that. Helps us if we are working on exactly the same set of hardware. I will admit on this build and on my more complicated builds, I use the Arduino Nano, which is pictured here, a link for that down below. Now, based on what comes in the kit, you can do all of the projects that I'm doing with the Arduino Uno that comes in the eLego kit, but you reach a point that it's just really a lot easier. It is time for me to move out of your way. Okay, it is just a lot easier to put the Arduino Nano on the board and then get nice, neat, crisp connections. And so you reach a point that you can do everything on the Uno, but the project just gets a lot easier if you have a Nano. So if you've made it through the first 54 lessons and you've made it to lesson 55, you've earned it. You deserve it. Go out and get yourself a Nano, because I will be using the Nano more in the future as we're going to more complicated projects. What we are going to do today is we are going to develop a distance meter based on the work that we did in lesson number 54 and lesson number 53, and we will be using the HC-SR04 most excellent ultrasonic sensor. And in lesson number 53, we got this hooked up. And so in lesson number 53, we showed you how to get it connected according to this diagram. And then we developed the code to operate the sensor. And the code that we developed, we got it to the point that the code was making a measurement and reporting in microseconds the ping travel time. And so you can see that as we move further from the sensor, the ping travel time gets larger and larger. And so what we are reporting over here is the time that it takes for a ping to exit the sensor, go to the target, and return from the target. So you have to understand the distance traveled by the ping is twice the distance that you're going to measure with a trusty ruler between the sensor and the target, because the ping has to go to and from. So we got to keep that in mind when we're doing this project. Okay, so get this hooked up. If you haven't done lesson number 53, go ahead and get caught up in 53, and it will get you to the point that we are showing here. And then just back behind me, just to recap, we have this signal hooked up to a oscilloscope, which you don't need, but it's just kind of neat to see that you see visually that up pulse, that one pulse, is a visual indication of the ping travel time. And then you don't need an oscilloscope, that just shows it, but we are able to get that same reading using the command on the Arduino, which we learned in lesson number 53, which was, if I come over here, which was the most excellent pulse in command. The pulse in command on that echo pin is what measures, I better give it a target there, is what measures the length of that up pulse, the high part, the up pulse measures that. Okay, enough of this rambling. Let's get right into this project. And so okay, couple of things I got to remind you of, and I want you to learn. If you are interested in copying and pasting code from the internet and then going and impressing your girlfriend with your project that you did, this is not the channel for you, because this isn't about you copying and pasting what I am doing. This is about you learning learning how I think, learning how an engineer thinks, because I'm not going to be there with you all your life. And you can't just go and copy and paste everything that you're ever going to do in your life from the internet. And the other thing is, copying and pasting from the internet does not pay very well. So if you really want to be somebody in engineering, you have to get to the point that you can take a problem, you can take a word problem, and you can turn it into a solution like this that you can put on someone's desk. And so what was the assignment that we gave you in lesson number 54? It was to go out and develop a distance meter where this thing that we have done so nicely here, that this thing is not reporting ping travel time as it is here, but it is reporting distance. We want the distance from the sensor to the target. So we want a distance meter. And so what is our task? Let's see what would be a suitable view here. I have so many views, it sometimes takes me a moment to see what the most suitable one is. Let's see. Okay, this one I think is going to be pretty useful. All right, we'll come back to that one. I'm just going to show you what I'm thinking out loud here. So what do we have right now? The sensor is reporting time. It is reporting ping travel time. And we have to be very mindful of units. It is reporting ping travel time in microseconds. And kind of like one of the most important skills you need if you're going to be successful in engineering school, or if you're going to be successful as an engineer, or if you're going to be able to go out and develop hobby projects on your own without copying and pasting from the internet, is you've got to know how to keep track of dimensions. Okay, you've got to know how to keep track of dimensions, and you've got to make the dimensions work. The good news is it's really easy if you'll just do what I'm showing you, and you can be very methodical. So the problem that we have is right now we have a report of time in microseconds. That's what we have. This is what we have. And what do we want? We have our haves and we have our wants. Okay, I know you want $1 million and a cool girlfriend or whatever, but what we really want this time is and maybe if you figure out how to do this, you can start finding your way to get some of the things that you want in your life. So these are our haves. We have microseconds, and what do we want? We want distance. Okay, now what did I just tell you? I just said you got to keep track of dimensions. So we have time in microseconds. What we want is distance in inches. Okay, so what do we know from physics? We know that distance is equal to rate times time. Okay, distance is rate times time. Now what do I want? I want distance in inches. Okay, I want distance in inches. Now the problem is my rate, okay, my rate is in what? Well, it is in miles per hour. Okay, now what rate is that? Well, it's the rate of the ping. Okay, it's the rate, it's the speed of the ping. What is the ping? It's a sound wave. How fast do sound waves go? We know that they go at 700 and let's say 65 miles per hour. All right, so we know that distance is going to be 765 miles per hour times time. Okay, and our time is in microseconds. Okay, so what is the first problem that I have? The first problem I have is I've got this hours and microseconds don't match, and so they don't eliminate each other to leave a distance. So I either need to change 765 into miles per hour into miles per microsecond, and then change miles to inches. But the easy way to do this, and this is, man, you've got to think about this, and if you guys would take 10 minutes to think, it'll make your life a lot easier rather than doing crazy things. What would be the easiest thing for me to do if I converted 765 miles per hour into something in what? Inches per microsecond. Why would I want to change 765 into inches per microseconds? Because I've already got microseconds coming off of time, and then it would be time in microseconds, which I already have, and then I have inches per microseconds times microseconds. I'm left with inches. So I can solve this problem and get the answer I want if I just leave my ping travel time. If I just leave my ping travel time here, just leave that in microseconds and just adjust my 750 miles per hour and change that to inches per microsecond. So let's do that. And there's a million ways to do it, but the secret is you just go across multiplying by things that are equivalent to 1 until you get the dimensions that you want. And so I have 765 miles per hour. Okay, and notice how methodical I am. Don't put miles per hour because that's not math, that's just shorthand. And don't put miles per hour, because then if I multiply by hours or something, I don't know if the hours isn't, if this hours is in the numerator or the denominator. I don't know where that slash ends. So one thing is always use horizontal lines on your units. So I have 765 miles per hour, and I want to go to inches per microsecond. So let's deal with the inches first. Okay, and so what I want to get rid of is miles, and so I'm going to put miles in the denominator. And what I know is 1 mile is equal to 5,280 feet. Okay, 1 mile is the same as 5,280 feet. Now I could have put 1 mile over 5,280. You can put whichever in the numerator and denominator that you want. Well, why did I put the 1 mile in the denominator? Because I wanted to get rid of miles in the numerator. Then what is my unit? My unit is feet. Okay, is that progress? Yes. Are we done yet? No. Okay, I did not want feet, I wanted inches. So what do I know? I know that 12 inches is 1 foot. So what do I put where? Well, I put the 1 foot down here, so it will eliminate that foot, and then I know that 12 inches. Okay, 12 inches. So now foot over foot makes 1, mile over mile makes 1. What are my units now? Inches per hour. Hey, I'm getting close, but I can't use hour. What do I want? I want microseconds. So I'm going to come here, and I'm going to have to write small because I put this out here, which I shouldn't have. Okay. So I got to get rid of hours. So since I want to get rid of hours and it's in the denominator, I need hours in the numerator. So 1 hour is how many seconds? 3,600 seconds. So now I am in inches per second, but I don't want second, I want microsecond. And this is where I'm going to have to be right small. What do I know? 1 second. Why did I put second in the numerator? Well, because I want to get rid of seconds out of the denominator. 1 second is how many? 1 million. It is 1 million microseconds. Okay, seconds over seconds make 1, hour over hour make 1, feet over feet make 1, mile over mile makes 1, and I am now in what units? Microseconds, inches per microsecond, which I want to be. Okay, so distance, let's just write what we want to code now. Distance is equal to what? It's going to be equal to 765. I'm going to go ahead and multiply all the denominators and then divide by all the numerators. So what do I have up here? 765, use your parentheses, times 5280 times 12, okay, divided by 3,600, okay, and then I also here have a million term, so 1 million, okay, and now this is in what units? It is in inches per microseconds, and so now if I multiply that by some number of microseconds, where do I get that some number? I get it from the Arduino, right? I get it from this measurement that we're making here. I get it from this measurement that we are making over here. So I take that measurement, and let's see if we can see this. What do I do to get distance? I take this measurement, I multiply it by 765 times 5280 times 12 divided by 3600 divided by a million, and I am left with units of microseconds over microseconds make 1. I am left with inches. Guys, if you don't understand this, we're going to do another lesson on dimensional analysis, because if you're ever going to be someone, if you're ever going to be a player in the high-tech world, if you want to be in the big leagues, you've got to understand dimensional analysis. And I will do a separate video just on this. Yes, it is that important. But let's come over here and let's see if we can get a code view that will keep my equation there. Okay, we have a code view with the equation, and let's see if we can start coding. Okay, the code that we already have is the code from lesson number 53, and that gets you to the point of having the ping travel time. And okay, this is kind of we'll do this for right now so that you can see that equation as we are programming. Okay, so what do I have here? Right at this point, I have measured ping travel time. So I have ping travel time, and I am printing it. But what I want is, I don't want ping travel time, I want ping travel distance. Okay, the ping travel distance. So I'm going to have to make that int ping travel distance. Okay, why am I being so precise? Because you've got to understand the difference between the ping travel distance, right? The ping travel distance is from here to here and back, and the distance to target is just this much. So there's a factor of 2 difference between ping travel time and distance to target. So let's say distance to target. Make that a variable. I hope I'm not making these too long. At some point, you're probably getting too long. Okay, so that is going to be equal to what? Ping travel time. Okay, and we're looking at this equation up here, and that ping travel time was this question mark here. Now I have to multiply it by all of these, and then I have to divide it by those. And so it is going to be ping travel time times what? And you know what? I'm going to put my entire numerator in parentheses. Ping travel time times 765 point times 5280 point. And you know what? This distance really, now that I think about it, these need to be floats, because they could be in between numbers. Float, right? The distance isn't going to be 1, 2, 3, 4, 5 inches. It might be 4.5 inches. So I better make these floats. And then to force it to always use floating point math when I'm dealing with floats, I put all the constants in with a period just to be safe, so it just reinforces that it's floating point math. Otherwise, you can get some strange things that happen where you kind of round fractions to 0, which can cause great pain and agony. So the numerator up here, right, we were looking up here, it was 765 times 5280 times what? Times 12. All right. Now that's everything in the numerator. Now we've got to deal with the denominator. How am I going to deal with the denominator? I'm going to say divide and use your parentheses so that you force the whole thing to be in the denominator. As a math teacher, the biggest advice I could give you is use your parentheses. Okay, so we are going to divide by open parentheses, and then what do we have? 3,600 point. Okay, that's a 3,600, and then times 1, 1, 2, 3, 1, 2, 3. Okay, why is it times? Because that parenthesis is putting everything in the denominator. So now I just multiply the denominator. So it's numerator altogether divided by the denominator altogether. Hopefully that part makes sense. And that is then calculating the ping travel distance. What is the ping travel distance? It is the distance the ping goes, which is from here to here and back to here. Okay, but what do you really care about? The user does not care about this nonsense of ping travel distance. What the user cares about is this distance to target. And what is that equal to? Ping travel distance divided by 2. All right, is this going to work? This is your moment of truth. And let's see if we can get a better view here. I wish I could see my shots more clearly. Okay, here I've got the ping travel time, the ping travel time. And when I download it now, it should give me a distance. Okay, I will need everyone to take a super good shot of coffee. I will need everyone to hold their breath. We are going to try to compile this. Oh, it downloaded. But does our answer make any sense? Our answer makes no sense. Somebody tell me why we don't have inches being displayed. Because the code is saying to print ping travel time. So after all of that work to calculate distance to target, we printed ping travel time. So distance to target. So why don't we just do a little bookkeeping here and kind of format this a little bit. Serial.print, just print your distance. Got to put the quotes if I'm going to print a string. Distance to target is okay, and then close that. All right, and then we print the number, and I'm not going to do a print line. I'm going to be very good, and I'm going to come down and say serial.println, and then I'm going to do space inches so that I give my, and look, I'm even going to put a period there. All right, now let's download this. Hold your breath. Oh, denied. Distance to target. I did not put a semicolon the line before. Hopefully you guys were. The problem was not the semicolon. The problem is out there. There is one of you who is not holding their breath. Hold your breath. Oh, denied. Same mistake twice in a row. All right, everyone this time hold your breath. One guy didn't. Everyone hold your breath. Oh, now what is this? Now this is not rookie mistake serial. Okay, everyone this time. Oh, distance to target. Boom. All right, I need to give you a better view though, where you can see this more clearly. Where is the good view where you can see that better? I do not like that view. I need to go in and organize these things better one day, don't I? I really do. Does this give it to you? No. Okay, this gives it to you. Okay, look at that. All right. Boom. Uh-huh. Giddy up. Yeah, giddy up. We got ourselves a distance meter. Maybe before I celebrate too much, we should check this thing. Okay, so it's saying about 1.6 inches. And if I look at this, if I look from the target here to this mark, I'm seeing about as close to 1.6 as I could imagine. What's one thing I need to do? I need to slow down a little bit. Slow down. This is coming too fast and too furious. So let me put a delay of dt, and yes, I'm going to be a good boy, and I'm going to use a variable. I'll come up here, int, and then I will say delay time of, let's put like half a second, 500 milliseconds. Okay, so you couldn't see that, but you know what I'm doing. I'm putting in a delay time after the print. And we are downloading. I didn't even hold my breath this time. That is how confident I am. Okay, 1.6 inches. All right, so now let's slowly move this away. Boom! Look at that. Distance measured, distance reported. Why? Because we know how to do dimensional analysis. Did we go download someone's program from the internet? No. We did the math. We developed it ourselves. And let's look at that. Let's see how close that looks. If I do this, it looks very close to 1, 2, 3 inches. Do you see this? Math works. You don't need those libraries. You don't need to cut and paste. You can do this yourself. Okay, that says like 5 inches. And if we get out the ruler, we can see 5 inches. I don't know if you can see that, but hopefully you're playing along at home. Okay, guys, this is really, really fun. Okay, I really enjoy doing this, and you guys let me know, did anybody do this homework? Did anybody do this on their own? Are you understanding dimensional analysis? Tell me something down there. Is it just like, okay, you watched me and you were completely lost and didn't have a clue what I was doing, but just typed in my equation and it worked? Or would you be able to do dimensional analysis on your own? Okay, there's two things that I want to do now, and what I'm really trying to do is I'm trying to teach you, and therefore I want the lessons to build on each other. And so this isn't a series where you just come in the middle. This is a series where you build up along the way. So there are two things that I want to do, two things that are very important for me. One is, it is bugging me how that is jumping around, and it's kind of glitchy. And it is glitchy because I think that that is printing off the screen, and so I'm going to make it IN period so that it isn't as glitchy as I am sitting here pontificating. We have smooth data going by. Okay, there's two things that I really want to do. I want to stop. Yeah, you see now that's going to be nice and neat. I want to stop and I want to just do a lesson on dimensional analysis because it's that important. That the number one reason people can't do projects is because they don't understand dimensional analysis. And you've got things like the Arduino reports microseconds on ping time, and the internet reports 760 miles per hour on the speed of sound, and you're trying to go in and look on the internet for somebody to tell you what the speed of sound is in microseconds per inch, and so or inches per microsecond, and so you're sitting there just blindly. It's like you're a blind man stumbling around the room, to where if you learn this dimensional analysis, you will really do a lot more things. The other thing I want you to see is, as happy as we are, you see nothing is moving here. Nothing is moving in our setup, okay, until I moved it, right? But nothing is moving, but you see we're seeing 3.22, 3.27, and what you see is there's variations, and sometimes the variations are more than that. It's just once I sit down and start talking about variation, then the variations kind of go away. But as we're doing this, there starts being uncertainty in the measurement, like 5, 4.85, 4.85. You see how there's variation, and so there is noise in the data. And how can we smooth that noise out? Because anything you do with real components, you're going to have noise, and you're going to have to figure out how to deal with it. Hence, I will have a topic on the low-pass filter and understanding a low-pass filter and understanding how to use a low-pass filter. So, low-pass filter filters out that noise. So, two really important things that you need to learn. You need to learn how to do dimensional analysis, and you need to learn how to build a low-pass filter. And those will be the next couple of lessons. Please leave a comment down below. You guys start interacting with each other too. You're sending me a lot of comments, but you guys aren't talking to each other. Would really like it if we could start developing a little bit more sense of community here, and you guys get to know each other, leave comments for each other. Okay, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.